The specifications of genuine air filters are exactly matched to the operational requirements of your compressor. Non-genuine air filters can have incorrect filter grades which, if too coarse, can lead to dust particles entering the system and compromising equipment downstream. Conversely, a filter grade that is too fine can become blocked quicker and reduce the air density entering the air end from day one, resulting in diminished volume flow, longer on-load times and essentially higher running costs. The calculation is simple. A non-genuine filter that restricts airflow entering the compressor by 5% directly impacts airflow leaving the compressor by 5%. Essentially, it has to do 5% more work to make up the shortfall, equating to an additional 5% on your machine's annual running costs. Genuine air filters also have an internal reinforced structure guaranteeing form stability when exposed to a pressure differential. The structure of non-genuine filters may not be as robust, meaning deformation or a complete collapse of the filter can occur when under load, causing seals to become compromised. In addition, using non-genuine parts voids your machine's warranty, so the net result shows non-genuine parts can represent a false economy. It's an inevitable fact of life that energy prices will continue to rise as we progress further into this century. Countries, and ultimately factories around the world, will face ever more stringent targets for CO2 emissions reduction. So it's vital that we use energy as sparingly and efficiently as possible for the sake of both economy and the environment. Approximately 10% of all electricity used in industry is accounted for by compressed air systems, and it's a thermodynamic fact that around 94% of this energy gets converted to heat. Heat that we first pay to generate, then pay again to remove by powering cooling fans, whilst in other parts of the factory we pay yet again to generate more heat for hot water, heating systems and application processes. There has to be a more efficient way of using this energy. Well, there is. Under ideal circumstances, 94% of the heat energy generated by compressors can be recovered, and Gardner Denver's range of heat recovery systems can help in utilizing that energy which would otherwise just go to waste. The principle of heat recovery lies in transferring the heat of compression into a cooling medium and then transporting the medium to where the recovered heat can be made use of. Within a compressor, the heat, which is created by compressing the air, is absorbed by the cooling oil. The oil, which is now hot, is circulated by pressure and flows through the plate heat exchanger. The heat is then transferred to the incoming water supply, heating the water at the same time as cooling the oil. The hot water can then be delivered for any application where heated water is required, such as steam generators, washing processes, boilers, heating systems, and many more. Every degree that we raise the temperature of water needs to be paid for. So if we have a water supply that is already 60 degrees Celsius higher than the standard water supply temperature, that's 60 degrees of heating that we don't need to pay for again. Preheating water for your heating system, hot water supply, or for use in industrial processes such as steam generation can provide significant savings and pay for itself very quickly. Additional heat that isn't captured in the cooling oil radiates into the canopy and exits the canopy roof as hot air. This hot air would ordinarily go to waste, but by installing heat recovery ducting, the hot air can be diverted to a different part of the factory, You can even switch the air to be diverted outside during the summer if it is not required inside the building. Installing a Gardner Denver heat recovery system can be surprisingly cost-effective and could be one of the best decisions you make this year. Oil filtration is key to extending the life of your compressor. Therefore, it's important you choose an oil filter that protects your investment right through to its next service. When using genuine oil filters, you are buying peace of mind, safe in the knowledge that your machine is protected exactly how the manufacturer intended. Cheaper imitations may look the part, but looks can be deceptive. Closer inspection reveals just how damaging non-genuine components can be. Seals, unable to withstand high temperatures over prolonged periods, can cause leaks. Element enclosures, not manufactured to our high standards, can rust over time or even rupture when exposed to high pressures, spraying hot oil over your machine or, even worse, the operator. And things may not look any better on the inside. There is no guarantee of filter media quality in a non-genuine oil filter. Rips or tears, sometimes caused by sharp edges within the filter, will lead to unfiltered oil entering the system. Genuine oil filters are fitted with a start valve, a critical component that can sometimes be omitted from non-genuine filters. This valve plays a crucial role when the compressor starts. Coal oil has a thicker consistency or higher viscosity, making it more difficult to pass through the filter media. When this occurs, a bypass or start valve opens, making sure adequate oil reaches the air end. Once the oil reaches its normal operating temperature, its viscosity decreases. The start valve closes, and the oil passes through the filter media. Regardless of filter media quality in a non-genuine filter, if its start valve has a flaw preventing it from closing, unfiltered oil will continue to pass through the system, drastically reducing the life of your compressor. Effectively, your machine would be running without an oil filter. Only genuine oil filters provide the guaranteed protection your compressor needs. Unfiltered oil can cause blockages, resulting in key components being insufficiently cooled and lubricated, causing damage through friction, warping from high temperatures, and a loss of pressure through rotor profile damage, all making your compressor run less efficiently. In the worst case, a component not receiving adequate lubrication can seize, causing catastrophic mechanical failure, leaving you with nothing more than an expensive repair bill. And don't forget, if something does go wrong, you're effectively on your own. Using non-genuine parts voids your warranty. Cheaper, non-genuine parts can sometimes seem like a cost saving, but they rarely amount to a false economy. Using non-genuine oil filters can lead to a greater risk of leakage, risk of filter enclosure rupturing, air end life reduction, reduced lubrication, lower efficiency resulting in higher energy bills, and not forgetting, using non-genuine components will void your warranty. In the interest of both cost and safety, it's vital that the air-oil separator in your compressor exactly matches your machine's requirements. Essentially, air-oil separation is the final filtration process within an oil-lubricated compressor. Its function is to extract and liquefy the oil present in the compressed air vapor and return it back to the air end. However, things may not go to plan if this critical component is made from substandard materials or contains unsuitable filtration media. Filtration media that is too dense will restrict airflow, creating an increased pressure differential across the element. Consequently, the compressor will continue to think its target pressure hasn't been reached, when in fact it has. The result: longer on-load times and increased energy costs. It also means your compressor has to work harder to generate the additional pressure needed to compensate for the pressure drop, putting unnecessary load on your motor and further adding to your energy costs. Multiply this extra power requirement across the life of the filter element and costs soon start to accumulate. As a basic rule, for every 138 millibars pressure difference between the pressure vessel and the delivery port, your motor becomes 1% less efficient, adding 1% more to your running costs. So a 100 kilowatt motor would consume an additional 1 kilowatt for every 138 millibars pressure difference. The greater the pressure drop, the greater the cost. Inadequate separation materials can also allow oil vapor to pass through, otherwise known as carryover. This not only contaminates pipelines and reduces the life of filtration and drying equipment downstream, but is also costly due to oil being lost into the network. There's also the danger that the machine becomes inadequately lubricated if oil levels get too low. A separator losing oil at 6 parts per million could lose around 5 milliliters of oil every hour, or 1 liter every 200 hours, adding more avoidable cost to your annual bill. In addition, there's the risk of a complete collapse of the air-oil separator due to increased pressure differential, or, if the element isn't suitably earthed, a fire caused by static discharge. And don't forget, if something does go wrong, you're effectively on your own. Using non-genuine parts voids your warranty. Cheaper, non-genuine parts can sometimes seem like a cost saving, but they rarely amount to a false economy. Any small saving made with the initial purchase price can be cancelled out very quickly, and then ends up costing more over the component's life with increased energy costs, loss of lubricant through carryover, damage to downstream equipment and pipelines, a potential fire risk, and not forgetting that using non-genuine components voids your warranty.
Air. It lifts us and propels us forward. Pneumatics, the science of controlling pressurized gases to create force and motion, moves us in a myriad of ways. Parker Pneumatic Technology is on board with hundreds of rail, bus and truck operators in thousands of places around the globe, building, maintaining and keeping vehicles running safely and right on time. Parker Pneumatics and System Solutions run so deep they can reduce assembly time by 70% and reduce suppliers from 8 to 1. Parker Pneumatic Technology is also moving full speed ahead in food processing, furniture manufacturing, and even the smelting of aluminium. Air may be something hard to grasp, but in the right hands, it's doing astonishing things. Parker. Engineering your success.